Okay, so far we have established that photons can act like a wave or a particle. They're little quantized bundles of energy, right? We've also now established that electrons can behave sometimes like waves and sometimes like particles. Both have what we call a dual nature. But what are they really? So imagine, if you will, that everywhere in the universe there is an electromagnetic field. But most of the time, that field has a value of 0. You can think of that as, oh, well, there's no field there. But no, it's actually that there is a field there, just the field has no value. And that sounds like the same thing, but it's not. It's an important distinction. And here's why. So when you drop a rock into a pond that has an altitude of 0, you end up with a ripple, an excitation, as it were. When you have a 0 value electromagnetic field and you whack it, you hit it, you excite it, what you end up with is a ripple in the electromagnetic field, a ripple we call a photon. So that explains the photon. What about the electron? Is there a field everywhere in the universe with a value that's usually 0, and when it's excited you end up with an electron? And the answer is yes. We call it the electron quantum field. The electron quantum field has a value of 0 almost everywhere. Excite it, and you get yourself an electron. Excite it somewhere else, and you get another electron, which is exactly identical to any other electron. Every electron is the same as every other electron. The electron quantum field can be excited in the opposite way too, and it can give things what is essentially like a negative energy, like a negative potential energy. And the resulting particle is almost identical to an electron in almost every way, except it's positive. Just like when 1 plus -1 meet, they get 0. When an electron and a positron meet, you get an explosion, a tiny little nuclear explosion converting the energy E equals mc squared into photons. We call this process annihilation. We're not done yet, right? What about protons and neutrons? Is there a proton quantum field and a neutron quantum field? Turns out the answer to that is no, because protons and neutrons are not fundamental particles. Protons and neutrons are made up of smaller particles still. Particles that you may have heard of before, they're called quarks. The word quark comes from Murray Gell-Mann, who stole it from a poem by James Joyce called Finnegan's Wake. There's a section called Free Quarks for Mr. Mark. And the proton is made of 3 quarks, and the neutron is also made of 3 quarks. And they're the same types of quarks, but in different combinations. The proton is 2 up quarks and 1 down quark, whereas the neutron is 2 down quarks and 1 up quark. But that's the fundamental particles of the universe that we see in normal, everyday life. But wait, there's more, which we'll get to in the next video.